All right, so concept one is something, and this is what it looks like in section 4.3 of your data packet. This is what they tell you, right? So what they're saying is that the intensity is some constant divided by x squared, where x is the distance you are from a source. So if this is your source and it's radiating energy in all directions, and say you're 1 unit away, right? Okay. If you're 2 units away, let's say the intensity is I naught, right? If you're 2 units away, it's going to be I naught divided by 4 because you're twice as far away, right? If you're 3 units away, it'll be I naught divided by, well, 3 squared, which would be 9. That's what they're talking about. That's what this means, right? If you're 4 units away from this, it'll be I naught divided by 16. So it drops off. Basically, what they're saying is that the intensity will drop off with the distance squared, okay? And this is just something that's ubiquitous in physics, and it has to do with the dimensionality of our universe, okay? So let's just take a little side trip here, okay? A little side trip. This is actually in D1, which is, we don't do this option, but it's in astrophysics. And this is how I would prefer to talk about intensity. So this thing, this brightness is actually the intensity, right? This luminosity is actually power, okay? This d is actually a radius, okay? So let's rewrite this formula the way I would write it. Intensity is power divided by 4 pi r squared. Now, if you're paying attention to math, okay, this is the area of a sphere. Okay, this is the power output. This is our intensity. So if you think about this, if you think about, let's say, a star that's spreading its energy in all directions equally, and you're standing some distance from it, say out here on the edge of this circle, imagine in 3 dimensions that that power is getting spread out over the surface of the sphere. Okay, so this is really all we're saying is that I is power divided by area. We've already seen this before, right? Only the area is, if it's spread out evenly, that is, it sends its radiation out homogeneously in all directions, okay? Then what's going on here is that power is getting spread out over the area of a sphere, the radius of which is the distance you are from that object, that star, okay? Obviously, you know, for a flashlight, this is going to be not exactly correct, okay? But there still will be like an inverse square thing going on, okay? It's just that this formula, you'd have to tweak it a little bit, okay? So I don't know if that sort of helps us, okay? This is the graphic that they use in astronomy, so we'll just use the same thing, right? We're 1 unit away. Notice that these rays are just spreading out, right? They're going, the rays of light travel straight. If we're 1 unit away, it makes 1 square. If we're 2 units away, if r is 2, then we get 4 units of area. If it's 3, then it's spread out so that it's 9 units of area. This is just a fundamental thing. Now, the cool thing is that if we look at the force of gravity also follows an inverse square. It's g m1 m2 over r squared, okay? And the reason for this is that gravity is mediated by particles called gravitons, which we haven't detected yet. But those particles are radiating from mass. So in a quantum mechanical sense, mass is the ability to radiate gravitons, okay? And so those gravitons radiate out and spread out over more and more area, and that's why the force drops off as r squared. Okay, if we look at the Coulombic repulsion between, say, let's say we have 2 positive charges, right? Those 2 charges are going to repel each other, right? And that force is the actual, well, okay, the formula we teach high school kids is kq1 q2 over r squared, right? But the real formula is this. It's 1 over epsilon naught. This is some constant that makes it all work, right? And then it's q1 q2 over 4 pi r squared. Now I sort of rearranged this so that it looks like this formula here, but this literally has this is the mathematical equivalent of the Coulombic force, okay? And in the case of charge, okay, the thing that mediates the electromagnetic force is photons, okay? And these are virtual photons that boil out of the vacuum of space because, I'm sorry, I'm going to blow your mind here, but because of the Heisenberg uncertainty principle, right? That uncertainty of energy, uncertainty of time is what, greater than or equal to lambda bar over 2 or something like that, or h bar over 2. But anyway, the idea that space itself is uncertain and the property of charge is the ability to create these virtual photons that boil out of nothing. I'm sorry if your brain is smoking, but that's what it is that these forces are mediated by particles that spread out over greater area. Okay, it has to do this. R squared is because of the 2 dimensions that the area of a sphere has. Okay.